So for this question, we can see we've got a curve here, and it's got the equation y is equal to 6 over e to the half x plus 4. We have region R bounded by the y-axis, x-axis, and the equation x equal to 2. So we want to show the area. So area, we know we're going to integrate to find the area under a curve, and we are showing that it's given by that thing there. So if you use the substitution, e is equal to half x, we are proving that if we basically start integration by substitution, we can change it into that integral there. So 12 over u plus u brackets u plus 4 du. So that's what we're doing there. We're not actually doing the integration. We're just doing the first bit and substituting in all the values and writing our integral in terms of u rather than x. So let's get on with it. So we currently are starting with this integral. So we are starting with, I've hidden it so I can't see what it is. There we go. So 6 over e to the half x plus 4. I'm going to write everything in terms of x to start with, including my limit. So my limits are 0 and 2, looking at my area there. So the limits are 0 and 2. So this question is just asking me to write it all in terms of u. So let's start with u is equal to e to the half x. I'm going to first of all think about writing dx in terms of du. So to do that, let's do du by dx and differentiate that. That will bring the half in front here, so it'll be a half e to the half x. And then writing that and making dx the subject. So if I multiply by dx and divide by the half e to the half x, so if I divide by half, that's the same as multiplying by 2, so that'd be 2 over du. And then we divide by e to the half x, and that will give us dx. And then let's think about e to the half x is u, isn't it? Because we can see that right there. So therefore, we can rewrite that as 2 du over u is dx. Then we also need to think about our limits, because our limits are in terms of x at the minute. We need to write them in terms of u, and this is a step that I think quite a few people forget sometimes. So x is 0 and x is 2. Let's rewrite those. So u is e to the half x, remember? So that'll be e to the half to the power of 2. That would just be e to the 1 or e. And then when x is 0, we're just going to end up with e to the 0, aren't we? Which would just be 1. So now let's have a go at rewriting our integral all in terms of u now. So our limits are e and 1, and make sure where there was a 2 you put the e, and where 0 was you put the 1. They should map to each other. And then 6 stays as 6. E to the half x is u, so let's replace that. Plus 4, and then dx we're replacing with 2 du over u. And let's tidy that up. So the 6 times by the 2, that'll make 12. So we'll get 12 on top, and then we can multiply the denominator by u. And that's all with respect to u. So I believe that is what we wanted. If I check the first bit of the question, 12 over u plus 4, yep. And then our limits b and a are e and 1. So we can go one step further and say, well, look, b is e and a is 1 for good measure. So that's part 1 of the question. And then part 2 of the question is using algebraic integration, show that the area is that. So let's do that. So now we are trying to, for part B, we are evaluating our integral and proving that we get that exact value. Remember, for exact values, we shouldn't be using decimals or anything like that. It will be, if it's an e, it will stay as an e. If it's a log, it will most likely stay as a log. We shouldn't be like converting things into decimals where they're not going to be exact values anymore. So now let's think about how we can integrate that, and let's think about which methods of integration that we know about. So it's going to be a more complex form of integration because we can't integrate that off the bat. We're going to have to use another technique. So substitution, we're currently doing substitution, so I don't think another substitution is going to help us here. I don't think by parts is going to help us particularly either here. So then I'm thinking, what's left over? Reverse chain rule, could we use that? And if it's a fraction, it would have to be in this form. So if we were trying to integrate a fraction, the denominator and the numerator need to have this relationship. The numerator needs to be the derivative of the denominator. If that's the case, we can just do the log of the denominator. But in this case, that wouldn't happen because we'd end up with a u squared term. And u squared, it would differentiate to 2u. We need a 2u on the top, which we do not have. So we can't use that. So at the minute, we're a bit stuck. In its current form, we are going to struggle to integrate it. So we need to think, can we rewrite that fraction in an alternate form, which would allow us to integrate it? And I think we can. We can use partial fractions to rewrite that, can't we? And separate that out into two separate fractions with denominators of u plus 4 and u. And that would hopefully be something that's a lot more easier for us to integrate. So that will be equal to a over u plus 4 plus b lots of u, sorry, b over u. So then let's multiply everything through by u plus 4u. So let's do that. So I'd end up with 12 here. I'd end up with a u, and I'd end up with b u plus 4. So now let's get our values here. So I'm going to first of all make u equal 0 to eliminate my a term. So that'll give me 12 is equal to 4b there. So therefore b must be 3. And then let's make u negative 4. And that would give me 12 is equal to minus 4a, making a minus 3. So now we can rewrite our integral like so with our partial fractions. So our limits were e and 1, and then it was a was minus 3, so it would be minus 3 over u plus 4, and then plus 3 over u with respect to u. So to make that easier for me to integrate, I think I'm going to put the 3 on the outside, because if we've got a constant term, that's we can shove that on the outside because it's not going to affect our overall integration. So I'm going to put that there and then make that, and I'm also just going to write that as 1 over u minus, I'm just going to swap them around like so. And then how are we going to integrate this? Well, this is, we're going to use reverse chain rule. So like I said before that we couldn't use, we're going to use that thing that I crossed out, because the denominator would differentiate to the numerator u, and u plus 4 will both differentiate to 1. So it would just be the log of the bottom. So that thing therefore now becomes log of u minus the log of u plus 4 with limits of e and 1. So now let's put in our limits. So we'd end, oh, I need to put my 3 there as well. Don't forget my 3. So that will now become, so we would have the log of e minus the log of e plus 4. And then that would be minus the log of 1 minus the log of, it would be 1 plus 4. So that would be the log of 5, wouldn't it? The log of 5. So now let's think about what we've got here. Well, log of e would become 1. Log of 1 would become 0. So let's think about what we're left with now. So now we'd be left with 1 minus the log of e plus 4. And then it'll be minus log of 5. So that would be plus log of 5. So I've got this, and I need to think about what did I actually want to end up with, because I was given, it was a show that question. So the question was asking me to prove that the area was this. So 3 log of 5e over e plus 4. Now, I can use my laws of logs here. I can see the minus e plus 4. I can see that bit there. And I know with laws of logs, dividing, if you're subtracting logs, you can write that as a division. But then I think about the top. I've got log of 5, but I've not got that log of e, which, well, actually, I did have it. I had it up here, didn't I? I had it up here. But I rewrote it as a 1. So this is just a case of being very, very careful, because I don't think it's a silly thing to write log of e as 1 and thinking that's probably the right step here to simplify it, but it wants it in this very exact format. So actually what we're going to do there is we're not going to write that as 1, we're going to keep it as log of e, because again, with laws of logs, when we have two logs added together, we can write that as a multiplication. Don't know why I'm missing my brackets there. So let's rewrite this and see if we can make it look like that. So I'm just going to change the order of it. So I have the log of e plus the log of 5 minus the log of e plus 4. So this thing, so remember our laws of logs, you can write that as 1 log. So it would become log of 5 times e, which would just be the log of 5e. And then I know you could probably do this all in one step. I'm just being really extra and showing you every single step here. So then we'd end up with the log of 5e minus the log of e plus 4. And then for this thing, we have a subtraction of logs. So now we can write this as a single log now. So it becomes the log of 5e over e plus 4. And then that's all multiplied by 3, isn't it? Because we've still got that 3 on the outside. So that would therefore become 3 log 5e over e plus 4, which I wrote that there, which is what we wanted. I'll just go back and check. But yeah, that's what we wanted. 3 ln 5e over e plus 4. So that is the question answered.